is Rebecca Werner and I'm a lover of nature and the natural environment, and that's why I chose to research the environmental effects of coal seam gas mining in Australia. Research claims that gas supplies will last for about 30 years. However, it is thought that greenhouse gases and the carbon footprint will far exceed the benefits of this cleaner burning fuel. The topic is consistently raised and highly controversial. One side argues that coal seam gas is a cleaner burning fuel that is more environmentally friendly, while the other argues the extraction process negatively impacts the environment by causing irreversible damage, especially to one of our most valuable and scarce resources, water. It was a web-based research project where information was located through Google, Google Scholar, YouTube and Curtin University Library search engines. The information had to be deemed appropriate, and that meant finding quality information. Comparing it with a web evaluation rubric helped with this. A lot of the information was complex and highly scientific in nature. This made interpretation tricky and at times frustrating. However, taking a look at visuals such as photographs, videos and footage helped a lot. Coal seam gas is a naturally occurring unconventional gas found deep below the Earth's surface. It is made up of approximately 97% methane and traces of carbon dioxide, nitrogen and other gases. In Australia, the highest number of mines are located in New South Wales and Queensland. Gas is extracted by one of two processes: horizontal drilling, the most common method, and hydraulic fracturing. This is often called fracking, and this process occurs in about 20 to 40% of mines. Fracturing involves injection of a fluid consisting of mostly water and sand into coal seam fractures. The fluid generally comprises of about 97% water and sand and a small percentage of common biodegradable chemicals. It is heavily diluted by the time it enters the coal seam. Extraction is unlikely to impact or deplete water resources in artesian basins, as water is regularly recharged and the coal measures are separated by impervious layers, which results in little impact on surrounding aquifers. There is no firm evidence to support that CSG breaches are responsible for methane pollution of waterways, including the highly publicised Condamine River. This is something that can occur naturally due to movement of underlying geological structures. Coal seam gas-associated water, a byproduct of the mining process, consists of sodium chloride, soda ash, sodium bicarbonate, and traces of naturally occurring chemicals, heavy metals, and radionuclides. It is difficult to treat and dispose of. Mismanagement of this water is probably the biggest threat to the environment due to its high salt content. Although escaping gases and some of the organic and inorganic chemicals associated with coal seam gas can impact human health, this is far more likely for people within the immediate vicinity of wells. Further research will assist in finding out more about the variety of chemicals used and the long-term cumulative effects these have on the environment. It would also be interesting to look at the ways the brine and salt might be reused, refined or desalinated within the future. Although the project has been linked to learning at a foundation to Year 2 standard, it is considerably complex and involved, rendering it difficult for children of a young age to explore at a deeper level. In the classroom at this level, the overall concept of CSG could be adapted for children to investigate and inquire about environmental changes caused by pollution, Australian water sources, natural gas resources and how they are used, and how human interactions threaten the environment and ecology. Thank you.